Did you know that NASA, the agency that reached for the moon, once plunged into Earth's deepest oceans? While most people associate NASA with the vastness of space, few are aware of its ventures into the mysterious depths of our own planet. This lesser-known chapter of NASA's history is as fascinating as it is surprising. In the 1960s and 70s, NASA embarked on a series of underwater missions to explore the ocean's depths. These missions were not just about scientific curiosity, they were crucial for developing technologies and techniques that would later be used in space exploration. This chapter of exploration is often overshadowed by rocket launches and spacewalks. However, the knowledge gained from these underwater missions played a pivotal role in shaping NASA's approach to space travel. NASA dedicated significant effort to understanding the dark, mysterious world beneath the waves. The ocean floor, with its extreme conditions, served as an excellent training ground for astronauts. The ocean floor presented challenges as alien and demanding as the lunar surface. The crushing pressures, frigid temperatures, and complete darkness of the deep sea mirrored the hostile environment of space. The deep ocean offered a unique analog for the hostile conditions astronauts would face in space. Extreme pressures, total darkness, and the need for life support systems are challenges common to both deep-sea explorers and astronauts. The need for advanced life support systems, robust communication methods, and innovative engineering solutions were all tested and refined in these underwater missions. These experiences provided invaluable insights that would later be applied to space missions. Solving these problems for underwater exploration provided invaluable experience and technology for space missions. The development of submersibles and underwater habitats directly influenced the design of spacecraft and space stations. The allure of the cosmos eventually proved irresistible, leading NASA to prioritize space exploration. Yet the lessons learned from the ocean's depths continue to inform and inspire NASA's ongoing missions, both on Earth and beyond. NASA's early interest in the ocean was a pragmatic necessity. The vast, uncharted depths of the ocean presented a unique opportunity for scientists and engineers to test theories and technologies that would later be used in space exploration. The ocean's environment, with its high pressures and lack of light, mirrored the conditions astronauts would face in the vacuum of space. The deep ocean, with its crushing pressures and isolating darkness, provided an extreme training ground for astronauts. It was here that they could experience the physical and psychological challenges of isolation and confinement, similar to what they would encounter on long-duration space missions. Underwater habitats simulated the confinement and reliance on life support systems experienced in space. These habitats allowed scientists to study the effects of living in a closed environment, where every breath and resource had to be carefully managed, much like in a spacecraft. These missions, like the SEAL-AB program, were crucial for understanding the effects of living in confined environments. The data collected from these underwater missions provided valuable insights into human physiology and psychology, which were essential for planning long-term space missions. Lessons from underwater expeditions informed the design of spacecraft and mission protocols for the Mercury, Gemini, and Apollo programs. Engineers and scientists used the knowledge gained from these underwater experiences to develop more efficient life support systems, better habitat designs, and more effective training programs for astronauts. Deep-sea submersibles and remotely operated vehicles offered invaluable engineering experience. These technologies, initially developed for ocean exploration, were adapted for use in space missions, demonstrating the interconnectedness of oceanic and space research. The ocean served as a proving ground for extravehicular activities or spacewalks, providing realistic tests of suit integrity and tool usage. By training underwater, astronauts could practice the complex maneuvers they would need to perform in the weightlessness of space, ensuring they were well prepared for their missions. The deep ocean held intrinsic allure for an agency dedicated to exploration. Inner space, Earth's least explored territory, presented new frontiers ripe for investigation. Studying the deep ocean could unlock insights into Earth's geology, climate, and the origins of life. Hydrothermal vents revealed ecosystems thriving on chemosynthesis, broadening our understanding of life's resilience. The ocean floor is a vast repository of geological history and untapped resources. The mystery of the deep was a powerful magnet, presenting an irresistible challenge to NASA's spirit of exploration. Exploring the deep ocean floor presents formidable technological challenges. The most immediate obstacle is pressure, with the Mariana Trench exceeding 1,000 times sea level pressure. Designing vehicles to withstand such forces requires robust materials and sophisticated engineering. Darkness and visibility are significant hurdles, requiring powerful artificial lighting and advanced sonar technologies. Navigation relies on complex acoustic positioning systems, as GPS signals do not penetrate water. Corrosion from saltwater necessitates the use of specialized materials like titanium. Communicating with deep-sea vehicles is complicated, relying on slow acoustic modems. Deploying and recovering equipment is hazardous, requiring specialized support ships. These combined demands make sustained deep-sea exploration a monumental task. The technological challenges of deep ocean exploration translate into immense financial costs. Building and operating deep-sea submersibles can cost tens of millions of dollars. Each mission incurs significant operational expenses, including fuel, salaries, and maintenance. The Apollo program consumed a colossal portion of NASA's budget, competing with oceanic research for funds. The financial realities dictated a need for prioritization. Space missions carried different geopolitical and public engagement weight, influencing funding priorities. The perceived return on investment began to favor space exploration. Space held the allure of new worlds and fundamental questions of cosmic origins. The deep ocean, despite its scientific richness, found itself in the shadow of lunar ambitions. The shift in NASA's focus was driven by the geopolitical climate of the Cold War. The space race against the Soviet Union was a competition for technological supremacy and global prestige. Space exploration captured the dreams and aspirations of millions. The narrative of space exploration was one of venturing into the truly unknown. Space exploration promised tangible benefits with broad strategic and commercial applications. Satellite technology revolutionized global communications, weather forecasting, and navigation. The institutional momentum within NASA increasingly favored space. The call of the cosmos proved to be an overwhelmingly stronger magnet for resources and talent. Prioritizing space exploration yielded extraordinary scientific discoveries and technological advancements. The Apollo program revolutionized our understanding of the moon's origin and history. NASA's robotic emissaries transformed distant points of light into tangible worlds. The Hubble Space Telescope provided breathtaking images and data, rewriting textbooks on cosmology. Technological innovations from the space program had far-reaching impacts on Earth. The sheer volume of discoveries in space continuously reinforced the value of this exploratory path. Space exploration ensured its continued prominence in NASA's agenda and the scientific community. While NASA pivoted toward space, the exploration of Earth's deep oceans continued. The mysteries of the deep sea remained largely uncharted, and the quest to understand this vast underwater world became a priority for many. The deep ocean, covering more than 70% of our planet's surface, holds secrets that could unlock new scientific knowledge and resources. The National Oceanic and Atmospheric Administration, NOAA, became a key federal agency for ocean exploration. With a fleet of research vessels and a team of dedicated scientists, NOAA has been at the forefront of deep-sea research, pushing the boundaries of what we know about the ocean. NOAA operates research vessels and advanced technologies to map the seabed and study marine ecosystems. These technologies include remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, which allow scientists to explore areas that were previously inaccessible. Oceanographic institutions and universities play a critical role in deep-sea research. Collaborating with federal agencies and private organizations, these institutions conduct groundbreaking studies that enhance our understanding of marine life and oceanic processes. Private philanthropy and commercial interests have also entered the arena of deep-sea exploration. Organizations like the Schmidt Ocean Institute and commercial entities are investing in new technologies and expeditions, driving innovation and expanding our knowledge of the ocean. Industries like offshore oil and gas have developed sophisticated underwater technologies. These advancements not only support their operations but also contribute valuable data and tools for scientific research, creating a symbiotic relationship between industry and science. Recent initiatives focus on leveraging new technologies to accelerate discovery. Innovations such as underwater drones, advanced sonar systems, and AI-driven data analysis are revolutionizing how we explore and understand the deep sea. Projects like the Shell Ocean Discovery X Prize spurred innovation in underwater mapping, This competition challenged teams from around the world to develop technologies that could map the ocean floor quickly and accurately, leading to significant advancements in the field. The torch of deep-sea exploration still burns brightly in the hands of dedicated stewards. These passionate individuals and organizations continue to push the boundaries of our knowledge, ensuring that the mysteries of the deep sea are gradually unveiled for the benefit of all humankind. The future of ocean exploration holds immense promise, driven by advancing technologies. Over 80% of our ocean remains unmapped and unexplored. Future expeditions will uncover new species, geological formations, and novel biochemical compounds. Technological advancements will be key to this new age of discovery. Artificial intelligence and machine learning will help process vast amounts of data. Improved underwater communication systems could allow real-time data streaming. Understanding climate change will be a significant driver for future ocean exploration. The search for life on ocean worlds like Europa benefits from our understanding of Earth's deep-sea ecosystems.